Welcome to Lesson 6, Function, Topic 3. Unlike previous video where we also discussed functions, the functions in this video are going to actually return some information using the Circuit Playground Express. We're going to explore this by playing around with the capacitive touch. So you may recall from video lesson 2, topic 5, that in order to work with the capacitive touch, there was a certain mapping that was associated with each capacitive touch. Now what you see here is on the left side, this is the actual label that's on the Circuit Playground Express. But when you use the read cap, you have to use these numbers. And it's not intuitive that these numbers would be associated with each of these capacitive touch. So what we can do here is we could create a function to allow us to more naturally ask for, hey, is the capacitive touch labeled A1 being touched? So let's get to it. So as before, when you create a function, the first thing you have to do is specify the return data type. Now we know that read cap returns to us an integer. So we're going to write int first. And then the next thing we want to do is we want to create a function name that's representative of what we want to do. So I like to keep them short, but still intuitive. So instead of using recap, I'm simply going to use cap. I think we can all appreciate that that's representative of the fact that we want to get the value from that particular capacitive touch. Now what I would like to do is to be able to specify like an A1, an A0, A6. And in order to do that, we're going to allow the function to receive a string. And we'll call it C. Let's put our curly brackets, and let's do this as well. Let's get started immediately. So in order to do this kind of mapping, we have to then convert the idea that if the person puts in A1, that means that we have to translate that to a read cap of 6. Again, if you recall from the mapping, that's the association there. So we can literally do that. If C is equal to A1, then we're going to return the value from the Circuit Playground recap with a value of 6. All right, so let's give this a try. So we're going to go to our main function, and let's simply do a serial print. Print line of a cap of A1. And hopefully you can see how easier this is in that you don't have to remember the mapping. You just have to say, okay, I want the value from A1. And let's put a little delay in here, just so it's not coming at us so fast. Let's go to upload this. Let's open up our serial monitor. Oops. Let's do that again. All right, so we see the values of 218. That's because I'm not touching it. Let's pull up the camera. Let's go find A1, which is right here. And you can see here now that the values are definitely over 200. But the other thing you'll notice is that the values aren't consistent. It seems like there's 1,000, 500, 300, 1,000, 900, 200. So they're all over the place. So maybe we could do something to fix that or improve on that. And the way we can do that is by perhaps taking an average of some readings over the course of a couple of quick milliseconds. So that's the next function I want to explore. The idea that, and by all means realize I'm not doing this for all of them, but you would complete this by doing something like this with the else if, and then check for let's say, what's another one? Let's say A2 gets mapped to 9, and I'll do one more, just so you kind of get the idea of what we're doing here. So yeah, it's going to be a little bit of work here, but later on, when you go to write your programs, notice how much simpler it could be. If you want to check for the capacitive touch labeled A1, you simply write this. So you do some work down here. Again, that's one thing to remember when it comes to functions. In the end, the work does have to get done somewhere. It's just a matter of where you do it. And also the ability to now reuse this function over and over again. All right, so let's go back to our next example, which is how we can maybe create an average of these values. So it's a little more consistent. So similarly, let's create maybe a return type of float. And maybe we could call this mean cap. And not like an angry cap, more like the mean as an average. And similarly, let's ask the user for what cap they want. And in order to do this, let's create a variable sum, set it equal to 0. And let's just add up a couple of values, which means we're going to want to use a for loop. And I'm trying to think. It looks like 4 values were good enough to kind of go through the whole range of possible values that were being displayed. And all we want to do here is let's do a sum plus equals, and let's add up those values. Now what I don't want to do here is I don't want to go through the process of trying to figure out which cap they refer to. So what I'm going to do is I'm going to use the function we just created, where if they give us A1, I'm going to make a call to this function, which knows that, okay, if they're passing me A1, I need to read the value from recap 6. So this is one function calling another function. Now lastly, we have to return some information. So let's return the average, which would be all those values that we read from cap down here that got returned back to us, and we added up into sum. Well, we got to take that sum and now divide it by how many values we accumulated. And we can see here we accumulated 4. Let's do that, and I think we should be fine. So now instead of I know what I wanted to do. Let's offer a small delay here, real small, maybe thinking like 50. Hopefully that should be enough. And let's change this up to mean cap. So now hopefully instead of getting that big fluctuation in values, we'll get values that are a little more in sync from one to the other. So let's go upload this. Let's pull up our serial monitor. All right, so right off the bat, we can see here the values are a lot closer in values. They're all 217. They're just fluctuating a little bit on the decimal side. Let's pull up our camera, and let's see what happens when we actually touch it now. Notice there's still fluctuation, but it's definitely a lot better. You can see here we're getting 600, 500, 700. We're not getting the thousands, we're not getting the 300, and that's the reason, and that's because we're doing an average. Now we can explore this a little bit more in terms of how we can possibly get even more concise values. Maybe we could lower the delay, increase the number of values we're averaging. Again, I'll leave that up as an exploration for you. Again, recall what we're trying to do here. We're trying to explore functions, and functions that return values. So the last thing I want to try out is, it is common when you work with capacitive touches to determine if any of the capacitive touches have been touched. So let's create that function, and let's have that return a value of bool. And what's a good name for this? Any touched? seems kind of any cap. Let's say any cap. Now, unlike the previous two functions that required information, this one doesn't require any information because we know immediately that we want to check all the capacitive touches. So similarly, all we have to do is create maybe a couple of if statements that goes through and checks all of the caps. So let's do a A1 and check for its value to possibly be over, let's say 300. I think that's an acceptable value. If it is, let's return true. Okay, let's now do another else if, and let's check the main cap of, I think we programmed A2 as well. I think we did up to 3. And if that's the case, then let's return true as well. And you can see it's becoming kind of redundant with it. Is there a better way of programming? Yes, there is. But again, I want to keep it simple, just to the fundamentals, which is using if statements to decide things. And let's see the last one. And I think those are the only 3 we programmed. So at this point, we also want to return an else, being that if none of the other previous conditions have been met, then we're going to return false, which means none of the capacitive touch pads were pressed. So let's try that here, and let's do an any cap. And hopefully what we should get is that if we press either the A1, the A2, or the A3, we should see the words, well, we'll see the 1 pop up on the screen. Guess, you know what? Why don't we do this? Instead of using a serial print, why don't we do an if statement that says, if any cap, if I pressed any of these caps, then let's turn on the NeoPixel. And we'll simply do the first one. That way we're not messing around with the serial monitor, even though we still could. Actually, no, I guess now we can't because I took it out. Okay, so if any of the capacitive touch pads have been pressed, again, realizing we've only programmed A1, A2, and A3, that we will turn the first NeoPixel on. Otherwise, we will clear it out. Oh, we can have some fun. Let's just turn it a different color. So we'll do 0 is 0, 0, and let's say blue. All right, let's give this a try now. Let's pull up our camera. So immediately we should get a NeoPixel blue because none of them are being pressed. So what I'm going to do now is I'm going to press A1. You know what? Maybe I should use red. I don't know if you can really tell, but it is white. So I'm gonna let it go, and I'm not quite sure why I lost connection over there. And what was the other one? A2. Where's A2? A2 is just above it, so it turns white. And then A3, oh, happens to be they're all in order. So A3 will be the one just before it. So you can see now I can press any of them. Either the A3, the A2, or the A1, and it turns to white. And that's a very convenient function to have. So I'm going to ignore that for right now. So let's look at the functions we've created. We start off with just a simple mapping of the capacitive touch pads so that we didn't have to remember that a value of 6 with the recap was associated with A1. We took this to the next level in that we saw the values fluctuated a lot. So we decided to use a for loop, kind of take an average of values over the course of time. Here it seems like it's a fifth of a second, 200 milliseconds. From that now, we then created another function that allows us to check to see if any of the capacitive touch pads were pressed. So these are all functions that allow us to do a couple things in our program. It's really up to your imagination as to what to do with functions and then how to incorporate them with your program. but hopefully you can see how your main program becomes a lot more focused on logic because the functions are doing the work. So let's go back to our presentation. So in this lesson of functions, topic 3, we explored functions that returned data types. We saw an integer, a float, and a bool, and we explored it all by simplifying the process of how we work with capacitive touchpads. Again, when it comes to functions, it's more about, what process do you want to either simplify or reuse a lot. So that'll become another video where we explore more of the thought process as to what should be in a function and how we possibly develop a more full program by creating functions that can do smaller tasks. So hopefully you're excited and enjoy.